Welcome to today's Tech Talk, and very happy that Daniel is giving his second Tech Talk. So many of you will know him from the PACAMS talk that he gave together with Kalle. And today he's going to talk about the new HSM system where all the data that you've packed with PACAMS is actually going. And yeah, with this, Daniel, the floor is yours.
Great, thanks, Flo. Yeah, great that you are joining this Tech Talk. I'm Daniel. I'm representing the DKRZ HSM team here. So there are a lot of people from the data management and the system department involved, testing and setting up the HSM system. And yeah, there's a lot of work going on in the background. And I didn't mention certain names here, but there are several people involved. And yeah, I will talk today. Just a second. Yeah. So first, some general information. So there will be a Google Doc URL posted in the chat, and if you have some questions, just write them in there, and we will answer them afterwards. And there are also some people in the background. Hadie and Carsten from System Department, Andrea from Data Management, who already have a look at these questions and order it a bit, and maybe also answer some questions already. Please keep your microphone all muted and your camera off, as you all do, as I see. Now the link is in the chat. Thanks, Flo. Yeah, and the agenda for today, I will first give a big overview. What's the background? Why do we get a new system? What's the time schedule? Then we'll see a brief, let's say, how the system is set up, a system overview, and then the main focus will be on the new command line tool called SLK. We mentioned it already in the last emails, and that's actually also the interface with which you will be, or most of you will be interacting with the system, and therefore that's the focus. And in the end, so we don't have an interactive session today, but we offer a training system for you on which you can already now train a bit SLK using the SLK. And I will briefly say some things on this. So why a new system? Why StrongLink? So in autumn, winter this year, we will get the new supercomputer Levante, and so it will be 5 to 6 times faster than the current Mistral, but it will only double disk space. And generally, we expect in future that the computing time is rising more and more. And therefore, we need some new methods, or we need to store where we have to increase the data flow from hard disk to tape somehow. And we also need to simplify, let's say, the retrieval of data. So we need to find measures that it makes easier for you to store your data on tape and retrieve it fast when you need it. And in the moment, the HPSS for many users, let's say it's one way. You put data there, and it's there, and you never touch it again, and that's it. And the idea is to let's say have in future a tape system more in a way. Okay, you produce data, you quickly move it to tape, then you get it back when you need it, and so you have a lot of hard disk space free for new simulations, and the data is stored on tape. So so there was decided that that's a software called StrongLink, which let's say drives the new HSM system. It's provided by the Christie, or it's installed by the Christie Data GmbH in Germany, and it's developed by Strongbox in the US and Canada. And StrongLink, up to now, it was made for different applications, so also storage in the background, but this interface, SLK, that I present you today, that is quite a new development. So they started developing it in October, and therefore it's still an ongoing process. In the moment, we are the main customer, but they expect to get more and more customers using this SLK, and therefore there will be also a lot of updates regarding this SLK in the next months. Coming back to the system, so you have here a table overview over the old the current HPSS system and the StrongLink system. So the disk cache, it's less, but it's still quite high. The throughput rate will be higher of the new system. We expect currently a double throughput in the next years, but when we look into exascale, direction of exascale computing, it will rise more and more. What is different in the moment, HPSS, we have one HPSS server and one backup that's on standby. The strong link system, it consists of 11 equal nodes. They share the load. And if you archive something, then the node which has the lowest load in the moment will take over your request. What's quite nice with the system, so we have 11 nodes in the moment. If we realize that the system performance is too low because more and more data are archived, we just put up four more servers or 5 more servers, add more tape drives in the background, and that's it actually. So it's quite nicely scalable, and that makes it what one could say ready for exascale. What is the disadvantage? And I will mention it also at the end of the talk a bit more in detail. We have this distributed system. It's a distributed metadata database, and that also means if I archive something, it goes via one node into the archive, and if I retrieve something, it might go back from another node. And this also means that if I do some operations, then not all nodes know at the same time the same information. They need to exchange this information first. And therefore, it might happen that it takes some seconds until information is really available on all nodes. And therefore, if I archive something on one node, retrieval might not work directly because there needs to be some data exchange first. So it's a disadvantage of the system, but at the same time, it comes with a big advantage that it's really nicely scalable. And also, if one node fails, the system still remains operational. And if a second node fails, we can still retrieve data, but we cannot archive data anymore. So it goes in a read-only mode, and that makes it quite stable if we have some hardware failures in the background. If you have already questions on this, just write them into the document. So the current time schedule is we are on the 6th of July, and we expect that in 2 weeks we will turn off the HPSS. We said before there will be one week offline time. It's 1 working week. If we count the days, it's actually 10 days because on Monday the 26th, we hope the system is online again, and all the new HSM system is online, and all the data is transferred. And during this 1 week, which is marked here in red, you cannot archive anything and you cannot retrieve anything. So that week is completely without tape archive. So it came quite quick now. We hoped to, so we said originally we give this 3 weeks warning in advance. So we just got the 3 weeks. And that's mainly the reason that we decided that we want to do it, let's say, before summer holiday for many people, and that when people come back from summer holiday and come back to work, that then the new system's operational. In the moment, in these 2 weeks, we started our official testing. We are doing benchmarks in these current 2 weeks, and and after that, we hope that all the benchmarks are successful and that we can turn off HPSS on 16th of July. If you have questions, so we have an FAQ online and we have a documentation online, and there are a lot of resources in them. If you are testing SLK, please have a look first if you find answers in FAQ and documentation, and if not, please contact support. The people who are in the moment dealing with the support questions on the HSM, they are all also involved in this testing and have a lot to do in the moment, and therefore it might take a bit longer that support questions are answered. So it might not take 10 minutes, but it might take 2 hours or 3 hours, or depending on how much testing involves in the moment. So just that you know, it might take a bit longer, the answers regarding the HSM system, or other answers are processed as normally. Let's go over to a system overview. So in general, the basic idea is that we have a strong system in the center, and the user sends requests to the strong system. That strong system, it copies the data from Lustre to Cage, to cache, and from cache to tape, and the other way around. And the user controls it via the command line. And the tool for doing this is Slk, as I said before. It has some certain features, which I like very much. It harvests metadata of certain file formats, and stores them in a metadata base. First, it stores the normal POSIX metadata, and then it also stores additional metadata from netcdf headers, mainly global attributes, but also some information from variables. And also some other file formats like audio files, documents, as I will say later, metadata will be harvested from. And there's a search mechanism. We can search and retrieve files based on, let's say, modification date, type or MIME type of a file, certain keywords, or also based on some netcdf global attributes. And that, we hope, simplifies usage of tape and also makes the reuse of data in the tape archive easier. And it's also possible to see whether files are only on tape or if they're in cache. I will show you later how it works. And that's quite useful if you need to retrieve data, then it will be faster when the data is already in cache compared to if it's data on tape. And as I said before, the system is quite nicely scalable. So here's a more detailed overview over the system. And what I want to show you here is first, we have, as I said before, we have the user who logs in via SSH to Mistral and uses the Slk to transfer data between the Lastro file system on Mistral, connect to Mistral and the cache of the HSM. And then we have another possibility to access it. It already exists now, and it will be very similar in future. This is X-tape access for users who don't want to access Mistral or cannot access Mistral. They have another possibility to access this data. Yeah, and that's in detail explained in our documentation. And due to limited time in this talk, I don't want to talk more about it here. But you have a help page here. The file structure or the folder structure in Strongling, it's very similar to the current structure in HPSS. You have folders arch, double, doku, but we will remove the leading HPSS. So there will be not this root folder HPSS and then the subfolders, but directly archive, double, doku will be root folders, and then follow project folders, user folders, as you know it. So, and if you want to restore all data on the new system and you have a file path, you just need to drop the leading HPSS and the rest, the remaining path remains the same. With this, I come to the command line tool. So it's called Slk, as I said already before. And what is maybe most important to say in the beginning, because I had some questions, it does not start a new shell like PFTP does, but it's rather like CDO, and operator. Slk works the same way, Slk, and you provide a class or command, how you want to call it. And if you want to use it on Mistral, you just do module load Slk and you get it. There are several main classes. Most of them I will explain in the next slide. Therefore, just as an overview here. So when you use Slk the first time, you need to log in. Slk login, it generates a login token on your local in your home directory. It's similar like Kerberos ticket you use up to now to access PFTP. Currently, a token is valid for 30 days. With this restart, maybe it is changed in the future, maybe it's increased the lifetime or shortened, but at the moment it's 30 days. You need your username, your password. Password is the same as for other DKRZ services, so your LDAP or your Louvre password. I added some notes here because this Strongling system, it caches the data, the user data from LDAP. That means For example, if the membership of your account changes, so there's a new project started and you get member in this project membership, this information is not directly given to StrongLink, but you need to log in again. And if you log in again, StrongLink gets a fresh user data set from your user from LDAP and puts it into its cache. And therefore, like you're a member of a new project, please log in again. If a user never logged into StrongLink before, then StrongLink doesn't know he's a user, then the user also has to log in first. That means for you, it's not that important, but if you ask us, the support, to let's say change the ownership of certain files because a user leaves his or her institution and the file should be given to another user, then this user has to log in at least once before. And when the user logs in, StrongLink gets the information. There's a background also. We have a lot of users in the LDAP, and only a few users of these will actually use the HSM system, and it would be unreasonable to copy all this data into StrongLink user database. If you ask for domain or host name, like password and username, then there's something wrong with the current configuration. Please contact us then. So, and now I will come to a brief comparison between Slk and Pftp, and by this I will explain the basic Slk commands. We have this section also in our documentation. Some abbreviations I will use. So if there's some lastro dir given, then it means some directory on the lastro file system, like this one I've given here, which is one of mine. And if I write tape dir, it means directory in the HSM. If there's a file.nc, it means it's a netcdf file. So let's have a look at Archival. So we want to archive data from lastro to tape. On the right-hand side, you see the Pftp commands. I won't go into detail into them. It's mainly as reference for those of you who are very familiar with Pftp, that you have a comparison. A basic archival of a file, it works like a cp command, Slk archive, source file, target directory. You cannot give a target name here. It's always the same name as already used for archive. When you want to archive all files in a certain directory, you just do Slk archive, source directory, target directory. You can also provide -r. When you don't provide -r, then all files from the source directory are copied, but subdirectories are ignored. When you provide -r, then the full recursive archival is done, so all subdirectories, the whole folder tree in this folder is archived. So the normal archive without -r, we could say semi-recursive. We are not quite happy with this, but we are not the only customer who will use Slk, and it was a design decision by the Strongworks to do it this way, and it won't be changed. Right. Slk retrieve works actually the same way. If we retrieve something, we can retrieve a file, and it's retrieved to a target directory. We cannot change the file name here. And the same Slk retrieve normally works semi-recursive, retrieves all files in this directory when without -r, and with -r it will also retrieve the subfolders. And I put an unequal sign here because on the right-hand side there's Pftp command, and if we do an mget star, then it also it's applied on files only and not on folders. And that means actually that's the behavior of Slk retrieve. It's quite similar to the current Pftp behavior. Then we can also list files, and actually list works like a normal ls. We say Slk list directory, and then we get an output which is very similar to the normal ls output. What's important here, I added a pipe here and a cat. Slk list normally goes into pagination mode, shows 5 results per page, and then you have to go to the next page by pressing return and so on. And that, for me, I find it's quite annoying, and therefore I normally just pipe everything in cat or in less or more, whatever is your tool of choice. And yeah, that's something I can suggest here. What we have also is in this permission string, which you know from LS, we have an additional column here, and there's a T or a minus sign in. When there's a T, then the file is only stored on tape in the moment. When there's a minus sign, then the file is available in cache. Might be also on tape, but it's at least in cache. And that means if here's a minus sign, then the retrieval of the file will go much faster because it just has to be copied from the cache hard drives to your local system. Instead, if it's on tape, then the file has to be first retrieved from tape into the strong cache, and then it can be retrieved. And depending on the load on the tape archive, it might take some time until the tape is fully read. And here's the date column just abbreviated. Slk list also understands -R to do a recursive listing of folder hierarchy. That's similar than the LS. Further features of Slk. So as I mentioned before, there's a search feature. And let's say we with a task, we want to list and retrieve all data of me, that's my username. And what we can do, we have a command called Slk search. We give a flag -user, gives the username. Then it takes some time. So it's not instantly, but the whole metadata base has to be searched. And you get a result. Here in this case, 720,430 files were found. And I get a search ID. And with the search ID, I can provide the search ID to Slk list. Then Slk list lists all of the files for me. Or I can retrieve these files by just providing the search ID from above as input to Slk retrieve, give a target directory, then the files are retrieved. You shouldn't do it to this amount of files, but yeah. This flag -user, you have it for user group and file name. There might come additional flags in the future. At the moment, we only have these 3. If you want to do, you can also do extensive search, an extensive search for more things. And for this, we go to the next slide. And I use the same example as before, but I use this extended search feature. So for the extended search, we need the ID of the user first, not the username, but the ID. And here we get the ID of my username. It's this here. And then we do Slk search, and then we provide a specific search string. There's a specific search query language that's strongly developed. It looks like JSON actually. And here we say, okay, we want resource.posix UID with this value. And there are things like POSIX GID, file size, file name, and so on. In the documentation, you will find a full list of fields that are available here. And this search structure is always the same. So there's a basic metadata schema called resources, which holds its basic resources, UID, file size, and so on. And there are other metadata schemata for netcdf, pictures, and so on. And if you want to search for, and always the structure is the same, you give here metadata schema name, here's the field name, and then the value you want to search for. And here in the search, you can not only insert fixed values. If it's an integer field, you can have larger or smaller. You can have a regex search if it's a string. A lot of different possibilities are here, and this query language is really powerful. It's hard to read, it's hard to write, but it's really, really powerful. And here you also get a search ID. You would also get a line with so many search results, but I removed it here, and then it works the same. Right, so you can search by metadata, not only by general, but by netcdf and other metadata. And so there's also possibility to set metadata to objects. In future, we will have possibility to really directly put it to individual files with the command Slk tag. In the moment, so we could in future, we can say Slk tag file name, and then we say, for example, metadata schema image, metadata field producer. We want to set this value Max Mustermann to this field. In the moment, I go to the last line. It only works for folders and not for individual files. It was design decision, and it will be updated later. But in the moment, there's no time set of developers to make this because they have other higher priorities in the moment. But what is possible, you can define a search and use the search ID, in this case, for example, 9, and set the metadata field image producer for all files within the search to this value. And by this, it's actually possible to update metadata of individual files if you do first a search to search a specific file. You get the search ID, use the search ID with Slk tag, and you add metadata. So it looks quite overwhelming in the beginning, and now it's quite much. We have, as for other things, we have documentation for it. We have a specific metadata documentation page where we give some additional examples on this. So I talked about metadata, and it was a bit cloudy which metadata is available, which not. So there are different metadata schemata available. So Storling comes from another field, and they have picture, document, video, audio, camera. So if you upload an MP3 file and you have nice metadata attached to it, then you will also have this metadata in a specific metadata schema. And all these schemas are listed, or available schemas are listed on this help page. Additionally, in the moment, we have a basic netcdf schema. Just for demo, it will be adapted, but it's there so that you see at least how this feature works and can use it a bit. In future, when the system is running, we will have 3 metadata schemata for you. The DKRZ core metadata schema with about 20 fields that are quite common fields and which are meant, let's say, for the everyday user. And then there's a header metadata schema, which contains about 100 metadata fields. And this some extended metadata also maybe for more automated retrieval of data. And all these metadata, in best case, they can be harvested from netcdf files automatically. So the netcdf header is read by StrongLink when we archive a file. If certain global attributes are set, then their values will be copied into this metadata schemata. And this is already possible with this netcdf schema in the moment. And then there will be a custom metadata schema which just contains 20 free-to-use fields. So that if you personally or you in your project want to add specific project-related metadata which has no specific field in the moment, you can just add it via these custom fields to simplify, for example, the search later on. Then we can change we have a Slk chmod, Slk group. Slk group is the same like change group, and Slk owner, same like change own. And with this, you can do normal permission changes, ownership changes. Slk owner can only be used by administrators. I'm just for completeness, I'm mentioning it here. It's the same like on the normal, like on Mistral, also only admins can do it there. Change group can be performed by owners and admins. Right. And the input is the same as you know it from the command line. So Slk chmod actually works the same way as chmod on the command line. And then another tool, which is, let's say, pure DKRZ development. So Slk is official tool from StrongLink. When there's a new StrongLink server version, you will get a new Slk version. Slk Helpers is an in-house development, mainly by Andre Fast. Big thanks to him. And it works the same way as Slk _helpers instead of Slk, has some additional tools which don't exist yet in Slk. So you can create directories. You can get a checksum of files. So StrongLink automatically calculates checksums for your files. And you can retrieve them if you want to validate that the file was properly uploaded. And additional information, it's all documented. What's quite nice is exist command. When you do an exist on a file, you see if it exists or not. And you get a unique object ID from this file. And this object also from a directory. And this ID might be useful in some searches. And if you load the Slk module on Mistral, you will automatically load Slk helpers. But I won't give any examples here, just and you see more information on the help page. Some general remarks. An extended version is in the help page. there will be a lot of text on the next 3 slides, but I thought it's quite important to have also this reference in this presentation. This SLK, it's mainly POSIX compliant, so it's mainly works like most command line tools you know from the terminal, but SLK was also made for Windows users and or users who are not so familiar with the Linux command line, and therefore there are some things which differ a bit, and also some other pitfalls that might appear. But first, to repeat it again, if you want to load SLK, just module load SLK. In the moment, it's the best really to use this and don't provide a specific version, because we have installed a lot of development SLK versions on Mistral. And in the moment, we care that if you load the default SLK module, then that will be the SLK that is compatible to the testing environment for you, or that is compatible to the latest running environment. And if you load another version, it might not be compatible. Where to run SLK? So first, it's quite memory hungry and quite CPU load hungry. It starts a lot of threads to be efficient in the archival. And this brings the downside that it's best to run only one SLK instance per user and interactive node. So if you're on Mistral PP1 working, please start only one SLK archive there. Second SLK archive also works, but if you start 5 or 10, they might get problems with each other. Different users can start their own SLK instance, there's no problem, but if one user does it on one specific node, then there might arise issues, and therefore our suggestion is do only one call per interactive node. We suggest use Mistral PP and Compute and Compute2 nodes, so interactive jobs, Mistral PP, batch jobs, these compute nodes. It's also possible on the shared nodes, but the shared nodes have less memory and therefore it's much slower, so the runtime is 2 to 4 times increased compared to the other nodes. And please also don't run it on the lock-in nodes, because SLK causes high CPU load and much memory usage, and it will slow down other users on the lock-in nodes. SLK does not print much information if something fails. Therefore, there's a log available in which debugging information, detailed error information is printed. A longer slide. Just have to look. We are a bit short on time, but I will mention a few things which I think are quite important if you're using it the first time. If you archived already a file and archive file or the file with the same name a second time to the same target directory in SLK, then it compares the timestamp and file size to determine whether the file should be overwritten or not. No other information. And this is the same like rsync normally also works. If you archive files, please wait a bit until you retrieve the file, because the system, as I said, it's distributed, needs to exchange information first. The same is also for checksums. If you use SLK helpers to retrieve checksums, it might take a bit, because checksum calculation might take long for large files and has a lower priority in the system. Therefore, it might take some time until checksums are calculated in the background. When these commands fail, SLK archive and retrieve, then there might remain file fragments. The same is valid for the CP command, but just to know it. If you archive and stop archival, or the job is killed due to timeout, a batch stop is killed due to timeout due to archival, then there will be a file fragment in strong link, but it will have 0 size. So if you do an ls on a folder which you archived before and you see a file of 0 size, which shouldn't have 0 size, then it's actually a bad upload. Oh, so if SLK archive stopped, have a look with SLK list, then you can find them by looking at the size. If you retrieve files, then SLK retrieve first tells the file system how large the file will be in the end. And therefore, ls will always print the final file size, also if the retrieval is still ongoing. You can only see the real file size via du. Or you can check the checksum to check if a file is valid, was correctly retrieved or not. SLK retrieve will never overwrite files. When a file already exists, then it duplicates the file and copies the newly retrieved file and adds a duplicate and a version number. If you do this several times, you won't get more and more duplicates. The duplicate file will always be overwritten by newer retrievals, but the original file will not be overwritten. Please don't call files. Please don't give a file a name according which could be duplicates. This might cause issues. If you kill an Slk archive call or general call, so some Slk archive commands have interactive progress bars. If you kill such a command, you will lose your cursor in the terminal. To get it back, the easiest way is open Vim and just leave it directly with full stop Q, Ausrufezeichen, and the cursor is back. If you do use Slk non-interactive mode in batch jobs, you don't see any textual output. There you need to capture exit codes of Slk and see is the exit code 0 or 1 and decide on this if what is successful or not. Error is in general written only to the standard out, not to the standard error stream. And then if well, normally you get an exit code 0 when the call is successful and 1 when it's not successful or higher than 1. If you provide a bad command to Slk, like you mix 2 characters in Slk archive, then the help will be printed. And since the help is printed successfully, exit code 0 will be returned. That's by design. We requested to change it, but it's a design decision, and therefore we won't get an exit code 1 there. Therefore, if you do scripting with Slk, be careful to check whether the command is really spelled correctly or not. If it's not correctly spelled and you catch the exit code, you will get a 0 anyway. You get an exit code of the last called command by writing $?. Okay, some final remarks on training if you want to train it. So we have installed it on Mistral. You can load this as module there. We have for you for testing the training software running on a virtual machine. So we are just testing the production system in the moment. Therefore, we cannot offer you working on the production system. Therefore, we offer you a virtual machine. It's powerful, but it's not really powerful compared to the production system. There's no connection to tapes. The storage space is limited. The data might be removed of any time. So don't archive data there. That's important. So can archive data there. That's important, but it might not be kept. It will not be kept. It will be gone when the system goes and when the other system goes into production mode. There's some training material here, and this VM will remain until the new HSM system is online. So during the offline phase of HPSS, this system will remain online and you can train there. But you have no access to the actual data with it. It's just a dummy environment. A few rules. If you work on the system, it is, as I said, it's not so powerful. Please start only one archival and one retrieval process at a time per user. Do only archive files of several megabyte size, better only kilobyte size. So don't archive 100 gigabyte files. So we have a basic, so folder structure is not the same as on the final system. We have a basic folder HSM, and you have write permissions in this folder, and you can create your username folder there. Please don't delete this folder. You will delete everything which is available in the test environment and will annoy some other users, I think. Please do not run benchmarks because it's not the final system. If you notify something strange, if there's an error in one of the Slk commands, just contact us via support at DKRZ. A summary, and it's actually a summary for Slk. So we have a new archival tool, we get a new hardware, and we are quite excited about it, and we get this new command line tool. It's similar to the Linux terminal commands, but not fully. You don't have an extra shell anymore like Pftp. It's made for batch processing and interactive jobs. Slk archive and retrieve, they work recursively. And you can retrieve files based on the file path, like it was always the case. But you can also search and return files based on search query. And you see via Slk list command if a file is stored on tape or is already in cache and can therefore be faster retrieved. With this, I come to an end to the question phase. And during the questions, I will just show the schedule again and our URLs to our support pages.